friends, welcome to my YouTube channel Automation Testing Online. In today's video we are going to discuss about test design techniques. Before jumping into the types of test design techniques, we'll understand why is test design techniques required. Test design techniques provides more structural approach in testing, resulting in better test coverage. Test design techniques helps the testers to identify complex test scenarios and reduces the risk of missing the defects. Helps in time saving. Coming to the types of test design techniques, we have error guessing techniques, equivalence partitioning technique, boundary value analysis technique, state transition technique, decision table technique. In error guessing technique, testers will identify the bug in a software application based on their prior experience, and they will identify a bug by entering negative scenarios. Here, they do not follow any rule. The testing depends on the analytical thinking of the testers. For example, if a requirement says that it accepts only numbers, testers will test by giving alphabets, alphanumerics, or alphabets with space, or even a blank space, or alphabets with uppercase and lowercase. Likewise, testers will give all possible scenarios and will test the application. This type of technique is called as error guessing technique. Equivalence partitioning technique. In equivalence partitioning technique, the test cases are equally divided based on positive and negative inputs. That is, the inputs are divided into partitions. The idea behind equivalence partitioning technique is to select any value from each partition only once. For example, an requirement says that only numbers from 100 to 500 can be entered in the text box. Normally, without test design techniques, testers will perform testing by entering the values one by one. First, they will enter 100 and then 101 and then 102 and then 103, so on. It is a long process. It is a time consuming process. They have to enter until 500, so it is a very long process. So to make it easier, we use equivalence partitioning technique, where we divide those test cases into partitions. We have divided into 0 to 99 and then 100 to 200, 200 to 300, 300 to 400, 400 to 500, 501 to 600. Any value that is selected between 0 to 99 is invalid. So if we enter any value, say 89, it is an invalid number, so the system should reject it. Any value that we enter from 100 to 200, for example, we enter 105. So 105 is a valid number and the system should accept it. Likewise, each value has to be selected from each partition, and any value that is entered between 501 to 600 is also invalid. Coming to example 2, let us consider that we have to select an age between 18 to 60 for voting. We have 3 partitions. Any value that is selected which is less than or equal to 17 falls under invalid. Any value that is selected between 18 to 60 is valid. Any value that is selected above or equal to 61 is an invalid. So this type of technique is called as equivalence class partitioning technique. Boundary value analysis technique. Boundary value analysis technique is based on testing the boundary values of a valid and invalid partition. Every partition has its maximum and minimum values, and these values are the boundary values of a partition. We'll understand more by looking into an example. If we wanted to enter a number between 1 to 10, let us consider that the range of value between 1 to 10 as A to B. Here we have to check based on boundaries, that is A minus 1, A plus 1, B minus 1, B plus 1. Here A minus 1 is 0, A is 1 and A plus 1 is 2. Coming to 10, B minus 1 is 9, B is 10 and B plus 1 is 11. So we have to choose the values based on their boundaries and then we have to perform the testing. Here 1 to 9, 10 are the valid numbers, 0 and 11 are the invalid numbers. State transition technique. In state transition technique, we pick test cases from an application where we have to test different system transitions. That is, we have to test different stages of the application. We can apply this technique when an application gives different output on same input, depending on what has happened on the earlier state. We'll understand by looking into an example. We have a food delivery app. We have already set the food delivery app in the form that if an user tries to enter wrong credentials for the third time, then the user's account has to be blocked. As we can see here, if the user in the first attempt enters the right credentials, then the user can order food. If not, the user has to go for second attempt. In the second attempt also, if the user fails to give right credentials, then comes the third attempt. The third attempt also, if the user gives wrong credentials, then the account will be locked. If in the second attempt user gives right credentials, then the user can order food. Similarly, for third attempt, if the user gives right credentials, then user can order food. So we have a lot of transitions in this technique. We have to test different stages of the system. This type of technique is called as state transition technique. Decision table technique. In decision table technique, we have to deal with a combination of inputs. To identify the test cases with decision table, we have to consider condition and action. We take condition as the input and action as the output. So decision table consists of the multiple combinations, conditions and rule criteria. We'll understand more by looking into an example. Let's say that we have a food delivery company where we are providing discounts to our customer. So the conditions are a new customer is provided with a 10% of discount and old customers provided with 20% of discount and a customer with a coupon code is provided with 30% of discount. In order to find the number of all possible conditions, we use 2 to the power of n formula. Since we have 3 conditions, 2 to the power of 3 is equal to 8. So we have to create a tabular column in such a way that we obtain different combinations of input. Here we have to create a tabular column with 9 columns including the conditions and 4 rows including the action. In the first row, in the first 4 columns, we have to give true and the second 4 columns we have to give false. Coming to the second row, in the first 2 columns we have to give true and the second 2 columns as false and so on. Coming to the third row, the first column is true, second column is false and so on. Since we have 3 conditions, we have to give true and false in such a way. We'll understand more about giving true and false in a tabular column in my next example. As of now, we'll discuss about this current example. We can see here that a new customer is true, old customer is true, and coupon code is also true. We cannot have an old customer and a new customer. So this condition is a fail. It is a failure. It is also a negative scenario. Coming to the second condition, we have a true, we have an old customer also true and coupon code is false. We cannot have a new customer and old customer, so this condition is also fail. Coming to the third column, new customer is true, old customer is false, coupon code is true. So new customer we are giving 10% of discount and a customer with coupon code we are giving 30%, so it is a 40% of discount. Coming to the fourth column, we have a new customer as true and coupon code as false, old customer is also false. So here we are giving only 10% of discount. And fifth column, we have an old customer and a coupon code. So we have 20% and 30% where we have to give 50%. Coming to the sixth column, we have only an old customer. So old customer we provide 20% of discount. And coming to the seventh column, then there is no new customer and there is no old customer. Without a customer, there cannot be a coupon code. So this condition is a failure, and or else we can do negative testing with this condition. And the last condition is everything is false. So this is also a negative scenario. So like this, we have to create different combination of inputs. Let's see a next example. Let's say that there is a login functionality where it will allow the user only if both the credentials are given correctly. So the first condition and second condition and action, we have 3 rows and 5 columns. Since we have two conditions, the first two columns are true and the second two columns are false. Coming to the second row, the first column is true, the second column is false, and so on. In the first column, if the condition 1 is true and condition 2 is also true, the user is allowed to enter the account page. Coming to the second column, email ID is true and if the password is wrong, it is an incorrect password. Coming to the third column, if email ID is true and the password is correct, it is an incorrect email. If both are false, it is an incorrect email. So this type of creating test cases with different combination of inputs is called as decision table techniques. This is all about test design techniques and its types. We will meet in my next video with a new topic. Thank you.